All right. So what I was just saying is we're just gonna go through really quick how to get these future study notes. Let me pull up the repo. Study groups. Here we go. All right. So first thing we're gonna talk. Oh,
excuse me. What do you mean when you say the repo?
Oh, by repo I mean this thing. I'm gonna share the screen.
Okay.
So this is our study group notes repo, where every time if one of our study groups is gonna have me going through a notebook, I'm gonna post that notebook up here, so you'll all have a copy of it as well. So what I mean was, on last week I worked on this section 1 notebook, and I had uploaded that a week ago, and 2 hours ago I updated this with a section 3 notebook. So the first time you do it, you just have to fork and clone. But subsequent times, I actually put the instructions right here. For subsequent times, you're just gonna do these steps. You're gonna fetch upstream, you're gonna merge the upstream with what you have, and then you'll push those new changes.
So you just go to that file on the bash and then just say fetch upstream. That's it, correct?
Yep, that's it. So yeah, well, not just fetch, but fetch, merge, and push as well. You have to do all of these steps.
Okay.
Yeah. So make sure you do that. So on Monday, I talked about like what all of this means. I have those diagrams on my tablet, but I haven't figured out how to export it yet. So I will do that eventually. So I have those like diagrams for you. So like I feel like for some people, having the visual of like what's in upstream and like what does it mean to like do all these things, for some people that helps. So I will get those out hopefully tomorrow when I figure it out. Cool. Any questions before we get started? I'm actually gonna go through the end of the section 1 notebook that we didn't finish. So talking a little bit more about dictionaries, and then really quick about like sets and tuples before getting into section 3 stuff.
One question I had. So today I was just, I attended that career.
Yeah.
Whatever it was. So in that, it was mentioned that they will want our LinkedIn profile and Git whatever it is.
Yeah.
So whatever we are right now currently making our repo or whatever we are doing, everything will be visible to them on that?
Yep.
Or only the projects?
Everything will be visible. However, everyone who's a student will have hundreds of repos. And so what you will do in the future for like employers, you're gonna have to you get to pin your projects to your profile. And when we get to projects, I'll show you how to do that.
Oh, perfect.
So don't worry too much about that. I actually really like to take the approach of like how will an employer see your work. So when we're working through projects, I'll make sure to like outline all the things to keep in mind. So don't worry too much about it yet. Cool. Let's see. I had mentioned to some people over one-on-ones, but like if Git is just too much for you right now, don't worry about it. Like you can totally skip over the sections if they're not really making sense, because I will go over Git again when we go over the project. I know like for some people, myself included, when I first saw Git, I was like super confused. So if Git is too much for you right now, I'd say like really focus on section 3, because section 3 is like really like the foundation of Python, and that's really something that we're going to build off of, whereas Git is kind of like its own thing. And I will talk about it again like in 4 weeks, so we'll get back to that. Any questions about like this repo, about any of the stuff that we've done over the past week? Cool. Then we can get started with a little bit of the end of section 1. So I'm actually going to start from the section 1 notebook, and I really want to highlight some intricacies about dictionaries that are going to come in really handy when we're looking at data. So a lot of data actually comes in the form of dictionaries, and so I think it's really important to remember these things. So over here, dictionaries, something to remember is that they're key value pairs. We know this, like these are the keys and these are the values. They are unordered, so you can't call a dictionary like you can't index a dictionary like you index a list. Like if you want to get like the first thing in the dictionary, if let's say you want to get this, they won't know, like Python won't understand what you're doing if you do like my dict index 0, because on its own, dictionaries are unordered. And finally, they're immutable. So that means you can update values of dictionaries. So just really simple to start, I have this dictionary over here, which I'm going to run. And there are a few things to remember that are like properties of dictionaries, is that you can extract parts of dictionaries in different ways. And that's like really the bulk of like what's going on here. And so let's just show my dict again. And here we have, it's a car. The brand is Ford, models of Mustang, and the year is 64. One thing that you're gonna see, especially in section 3, is dictionaries have this dot items method. So anything that is like a dot something that you have like parentheses at the end, it's a method. And so when you do dot items, notice what happens is that first it's wrapped in this items object, but on its own, if we ignore that, it's actually a list of tuples. And so tuples are basically anything that's in the round parentheses, and I'll get to tuples later as well. But it basically converts something from key value pair to tuples. And the important difference from tuples and key value pairs is that tuples are ordered. So that's important. So there will be some things that you'll need to like call in the dictionary items. If we look really quick, the type of the dictionary is a dictionary, and the type of items is it has its own class, or it has its own like data type. Has anyone ever tried to coerce a dictionary into a list? Does anyone have any ideas of like what's going to output when you try and coerce something like this into a list? List being like the square bracket ones that we saw last week.
An error?
An error? Not exactly.
Maybe give you all the variety.
In one list.
Sorry, can you say that again, Jeremy?
Well, put the whole key value as one index in the list.
Those are all good guesses.
Maybe we list all the dictionaries that are available.
That is also a good guess. So actually, surprisingly, when you coerce a dictionary into a list, and this is important to remember because sometimes when you're trying to like loop through a dictionary, that gets a little messy, but what outputs? What are these?
Oh, they're the keys, right?
Or
Yeah.
the columns.
So what is output when you coerce a dictionary into a list is it only keeps the keys. It only keeps like what's before the colon in a dictionary. So that's something that could be useful in the future. If you want to just get like a list of all the keys of a dictionary, you can just coerce it to a list. So can anyone make a guess of like, if I were to do like for I in my dict, print I, does anyone have a guess of what's gonna output?
It'll print that variable. My what did you say? My dict one.
Ooh, my dict was this.
Yeah, it'll bring back that, right?
So you think you'll like, what exactly do you think will print out?
It will print out
the pairs, right? The tuples.
Maybe actually. So this is actually something that like it's kind of a trick question. But if I were to loop through a dictionary, again, it only prints out the keys. That's very interesting. Is that like in a dictionary, if you treat it as something iterable or something like a list, it will only print its keys. So the main bulk of a dictionary is really its keys. So instead, so that's where my dict.items comes in handy, because as you see, items kind of like saves both the key and the value. And so we have here this part, and let me just like print the dictionary again. So like, we don't have to keep scrolling up and down. So this is a dictionary. Now if I have the my dictionary.items, what do you think is going to print now?
the values for those keys.
The values for those keys. So let's go back and actually look at what the dictionary items is. I did dot items over here, right?
Oh.
And in my dict.items, we actually had this was the output. So in that case, anyone else guess?
I think it'll print all of that.
All of that?
I guess, Michael, what is the difference between the tuples and the list? So
Yeah.
is it just that they can't be mutated, or?
Yeah, so
Okay.
as you can, so here it's a little confusing to see, but here we actually have tuples within a list.
Right.
So each of these is a tuple, and
Right.
they're housed in a list. And yes, the main difference between a tuple and a list is that tuples are immutable and lists are immutable. So if you wanted to like change like a value in a tuple, you can't do that. You'd have to create a new tuple. So yeah, this is a little bit confusing, and like the intricacies of dictionaries take a little bit of getting used to, which is I have like all these examples here. So hopefully like this is like a good, you can see like all the possibilities. But yeah, if I were to print my items here, they print these as individual tuples. Yeah, starting to like make a little bit more sense. And to just confirm, instead of printing the items, I'm printing the type of items here in this step. And we can see that they're each tuples.
Tuple.
Does the tuple always have two items, or
Maybe-
tuples with 3 or 4 items, whatever?
So you can have tuples with as many items as you want. Very typically, you don't really do that with tuples just because of like, it's not mutable. And so that you can't make changes to things. And like, if you want to make changes to any tuple, you would have to like just keep making new ones. And very typically like tuples help like keep data together. And I think, for example, like in this case, the tuple is immutable, and it's important that it's immutable because you always want brand to be with Ford and you always want model to be with Mustang. So tuples are in that sense good at keeping data that you don't want to like mismatch together. And we'll see more of those examples as we in the next couple of weeks.
How do we differentiate between a tuple and a list?
So tuples have the round parentheses, whereas lists have square brackets.
Okay.
Yeah, cool. So
Can you index them? Like, could you do I1?
yeah, absolutely. So here we can do I1 for the tuple.
Okay.
And you can see that it'll take the second value, and I0 will give us the key. And that's kind of a sneak because I'm going to talk about lambdas later. I know, Baja, you have been like yelling at me about lambdas, which is completely fair. But anyways, let's like finish up this part and then we'll get to that. So really quickly, just wanted to go through like how we can add things to a dictionary and update things to a dictionary. So here I'm just creating 2 empty dictionaries. And here, I want to basically repopulate this dictionary with that old dictionary. Does that make sense? So the old dictionary was this one. And I'm basically wanting to repopulate this with the old stuff. So what I'm doing is I am running a for loop through my dict.items, which again, let me just print out what that is. I'm going to loop through this, and don't worry too much about like this outside part. It's just like, it's, if you were to just like print through a print statement, it'll be a little cleaner. There we go. Never mind. I was wrong. But anyways, we're basically looping through this list of tuples here. So each I is going to point to a tuple. And how I update or add things to a dictionary is you call the dictionary, index it by the key you want, and assign it to a value. So in short, we're going to call dictionary, and we're going to index by whatever key you want, and you're going to set it equal to the value that you want. So that's how you add things to a dictionary. So in this case, I know that I0, which is like the first item in each tuple, is going to be the key, and I1 is going to be the value. So therefore, with this for loop, I can repopulate this dictionary. Any questions?
Oh, when it repopulates, is it forward and forward now, or?
Not exactly. So let's see what it does. So here we're taking I0, each I0, which is like the first thing of each tuple, will be the key. And then I1 will be each of the values. Does that answer your question?
Yeah.
Yeah. I know this takes a little bit of getting used to. I'd say like with this notebook, play around with like assigning random things to your dictionary. Like I could even do, so call the dictionary, new dict. Let's say I want to assign like, maybe I want to keep like the color of the car. So let's say I make a new key called color, set it equal to red. So I do that. And once I do that, this is a destructive operation, if we remember last week. That's less important, but we can take a look at what dictionary says now. You can see that now it has the color red. So this will be the new key, and this will be the new value. Well, yeah, it takes a little bit of getting used to. I'd say like sometimes the labs go like way too deep on something super fast. So like if this, because these are like really small examples, if you want, I think for some people it's a good idea to like just play around with these small examples and try to like figure things out that way. I think it's easier without like having like a gigantic dictionary like a lot of the labs do. So that's how you add something to a dictionary. That is one way to add something to a dictionary. Another way is using update. So there's a dot update, and a dot update, you can see that it takes in a tuple. Oops, hold on. I need to reset this. Let me do this. I'll turn it to second. All right. So for I in my dict.item, so actually let me just move this down here. What I'm doing here is I'm looping through this again, and I'm gonna update new dict2, which is currently an empty dictionary. So what's gonna happen, oh, damn, what's wrong? Hold on. That is weird and not supposed to happen. Huh. Give me a sec, sorry you guys. You know why? Because I reset my dictionary. Let me do this. All right, so this should. Okay. I take the items. Okay, I don't know why this isn't working, but this is another way to update a dictionary. So like if you have a dictionary and you have a bunch of new keys to it, you should be able to pass it into dot update, and it's supposed to be able to add new keys to the dictionary that way if you pass it in a list of tuples. Why this is not working right now, I don't know. But anyways, we're gonna look at another way to do this. Is using 2 arguments in a for loop. So far, we've been used to doing like for x in something. Something that I want to show you, that if you have a tuple, if you're looping through a list of tuples, you can actually give it 2 temporary variables. So the typical letters that you use here is K and V for key and value. And actually, before I assign this to the new dictionary, I'm gonna actually print K, comma, V. Or actually, let's print K, point that that's the key, and then print V, and then point that that's the value. So let's do that, and let me comment this out first. So as you can see here, if you have a list of tuples, and let me bring this a little bit down. If you have a list of tuples, you can point to each value, or you can point to each thing in the tuple with a different variable, with a different temporary variable. So as you can see here, it automatically knows that, okay, in each of the elements of this big list, we can split each of those things into two parts. Like it knows that a tuple is also subscriptable or indexed. It can be indexed. So it knows to assign k to the first one and v to the second one. And that's also something that can come in handy. Does that make sense?
Yeah. What if you only wanted to point towards like the value, the second one?
Mm-hmm. So usually in this case, you would still point to both, but then in your function, you would just use the value. But like for that specific case, right after this, I'm going to talk about that exact example. But this is just to show that if you want to iterate and like maybe use your two variables in a different way, in different ways, you can do this. So like, for example, if I want to like have a function that does, I don't know, something spicy like print v dot k, v plus k, because that's an integer, so don't worry about that. As you know, like with strings, you can add them together. So it says Ford brand, Mustang model. And that's how you can use the two variables like independently within this for loop. So that's a really interesting functionality that we might use towards the end of this session. Cool. Yeah, this is just because 1964 can't be added together with year. All right, and finally, I think I talked about this the other day, last week with like when you do like range length, so I won't talk about it again for the interest of time. Really quickly, very similarly to how we had dictionary.items, there's also dictionary.keys and dictionary.values. So Jeremy, to your point, if you just want to deal with the values, you can just have the dictionary values, and you can loop through this as well. And you see it's just like in a list.
Mm-hmm.
Similarly, in a dictionary, you can call for its keys. And they each have their own data types, where literally keys, values, and I'm just going to print them out here. Oops, wrong button. Just like that. And you can coerce it to, this is me coercing the list of keys into a list, and then just pulling out the first one. So knowing that like you can pull out the keys, values, and the items of a dictionary and like how you loop through them can come in really, really handy, especially when you're dealing with like gigantic dictionaries. Any questions about dictionaries? It's probably one of the most commonly used data types.
So now, how do you actually pull dictionaries into the books, or like it's already you have to download it, or you just pass some?
Like how do we get a dictionary onto your like notebook?
Yeah.
We're actually going to talk about that in section 9. Usually, like you'll have for all our labs, we actually, if you've noticed that for all our labs, we have like CSVs that come with the labs that you're like importing data from. So there's that, but there's also ways to like get data from elsewhere, and I'll show you that in section 9.
Okay.
Cool. So really quickly, just a couple others. I'm not going to talk about control flows because we're going to go through that more in depth right after this. But just really quickly, what are sets? Sets are like dictionaries, but they're not paired. They don't have key value terms. They're also in the curly brackets. But the thing about sets, the values have to be unique. So here you can see that like I just coerce something, and by putting the brackets, I put 1, 2, 3, 3, 4. And when I output my set, it gets rid of the extra 3. So sets are just like unique values. So it's actually very, very, it's very useful. So let's say if you have like a list of values going like 1, 3, 3, 5, 6, 7, 8, 8. Let's say you just want to get like the unique values. It's sometimes helpful to coerce it to a set, and that's how you can get the unique values of stuff. So that's mainly what sets are used for, to get unique values. And finally, we had already talked really quickly about tuples, that tuples are immutable. And as Henry had asked earlier, they can be of any length. But typically, I haven't really seen tuples go more than like 4 or 5. They're mainly for like if you want to keep points of data together. So just to show that they're immutable, here I have tuple that's just 1, 2, 3. If I want to reassign the middle element here to the number 4, they won't let me do that. See, it literally says tuple doesn't support item assignment. So that's
Can you
just
add on to the tuple? I feel like you can't change the 1, 2, 3, but if you wanted to, append or something, probably not that. But can you add?
Add element to tuple Python. So you can't add elements to tuple because of their immutable property. Yeah.
Okay.
Cool. So this is just like wrap up like the data types of Python that you're gonna see. Mostly like I wanted to highlight all the different like intricacies of dictionaries because those are gonna come in handy. All right, now, any questions before I move on to section 3? Actually, before section 3, at the head of section 3, I'm gonna talk about lambdas and also like list comprehensions, which we saw in that Macbeth section 1 thing. A lot of people were like, a lot of one-on-ones have been like, what is this? So I'm gonna go through it as well. So any questions before I start getting into this? Cool, all right. So lambdas. I've told a couple of you, but I have only used lambdas in 3 different ways. One of them is to do sorting, which is the lambda that turned up in Macbeth, and I'm gonna explain how that works. I use it in maps and filters, and that's considered as like one thing. I would consider that as one thing, and also in pandas. So pandas I'll talk about next week because we actually talk about pandas next week. So don't worry about that for now, but I'm gonna show you how lambdas are used in the first 2 ways. So this is just the code from that Macbeth lab. I copied it over, and then this is just the steps until we get to that lambda function. So if you remember, what we're doing here is we're creating a list of tuples that has the word and how many times it appears in Macbeth. So as you can see here, this counts is a list of tuples where we have like a bunch of words and then the number of times it appears. And what we wanted to do was get the 25 most common words. And we had this sort function that sort of like came out of nowhere. So how we use sorted is because we want to sort this list, not by, so by default, if you call sorted on counts, how does it sort? It sorts based on the string. It sorts based on the word because that's the first thing that Python sees. And so it's like, oh yeah, if you want to sort it, of course you sort by the left element first and then the right element. So that's what's happening first. And that's why we have to edit this sort. We have to add something to this sort such that it sorts it by the count, which is the second element of each tuple. Cool? So let's go back and look at what counts look like. All right. So what we have here is very similar to what I did earlier with just the sorted. All it is that there's this second argument where you have to tell it the key. You have to tell it how to sort. And the way it uses lambda is, when I think of lambda, I think of like, okay, lambda x, and x is basically gonna point to every element in that collection that I want to sort. I'm gonna say it again, x will point to each element in the collection that I want to sort. So in this case, each x just refers to the tuple. And you wanna tell it that you wanna sort it by the second element of the tuple, which is why you're telling it the key is x index 1. So that's how it gets the sort to sort by the word count, which is the second element, rather than the first element. And then reverse equals true is just another argument. And here we're just taking the top 25. So let's see what that looks like. There, awesome. That's no surprise that those are the words that come up first. Any questions about that? I know the concept of lambda is kind of confusing, but I think like for our purposes to understand them in these specific contexts is good enough.
So it knows to look at counts because you put the variable first, like this counts I guess when I look at the key, how does it know what the key is?
Yeah. So counts. Yeah, we always put counts first. And actually, let me look up the
Is count?
sorted. So counts refers to that list of tuple.
Okay.
So let's take a look at the sorted function. So the sorted function takes up to 3 things. One is required, which is the iterable thing, which is like the list, the dictionary, the whatever. The key to execute to decide the order, and then whether it's reversed or not. So usually it would be in this order. Does that make sense? Yeah. So that's how the sorted function works. And it's just like one of 3 ways that I use lambdas. All right. So that's that. Did anyone else have a question? All right. So this might have been something that I think was in the bootcamp prep, where you want to map things, and I'm not sure if filter was in there too. So I'll go through that really quick. So you can use lambdas if you would use lambdas in this situation if you want to do a certain function on every element in a list. So really quickly, I have this list L that's 1, 2, 3, 4, 5, 6. This syntax, which I'll break down a little bit, is going to map x plus 2 to every element of the list. So what I'm doing here is I'm just adding 2 to every element in the list. And if I output that, you can see that it's 3, 4, 5, 6, 7, 8. So every element went up by 2. If I break this down, map is the function that tells Python that, okay, I want to do something to every element in something else. So map actually takes 2 arguments. So if you can see here, there's a comma here. So it's split up by this lambda part, where as I think is very similar to how the sorted works, x refers to every element in the list, and it points to basically x plus 2, which is what I want to do to each element in the list. And then I also have to feed it in what I'm iterating over. Does that make sense? I know it's kind of a lot, but I'm just feeding it in the function that I want to perform, and then the list. And then the map does that on its own, but usually you want to coerce it back to a list so that it's in another iterable format. Because I think if you go back to map, it's in like a map object. See, so it's just an object that you can't really see. And so that's why you have to coerce it to a list. Does that make sense? Yeah, this specifically is not a very common thing to do, and I'll show you why in this next part. But something that I actually use a lot is I use the filter quite often. So in this case, I want to filter and only keep elements that satisfy the condition of being an even number. And so the syntax is very similar. Just instead of like a function or like an operation that I'm doing, I'm actually putting in a condition where x modulus of 2 is equal to 0. And basically that means that there's no remainder when you divide the number by 2. And here instead of map, I'm actually filtering. So this lambda part becomes the filter condition, and this is the same list. So doing that, I end up with 2, 4, 6, all the even numbers. So this is actually something that I think is kind of handy. I don't know, probably there'll be some labs that are coming up that you want to filter something, and you can totally do it using like an if statement in like a for loop, but this is sometimes like a little faster, a little more elegant. Cool. If not, there's one last way that you could do something like this in a way that I think you also saw in your Macbeth lab, where you had like a for loop within a list. And that's called list comprehension. And list comprehension is a very Pythonic thing. I think, correct me if I'm wrong, but I don't think many other languages support list comprehension. I think list comprehension just makes things seem a lot cleaner. So let's say I wanted to do this same thing. I wanted to like take this list of 1, 2, 3, 4, 5, 6 and change it to 3, 4, 5, 6, 7, 8. Someone who doesn't know like about map lambdas or about like list comprehension would do this, right? You would make a new list, iterate through L, and then append x plus 2 to the new list. And that gives us the exact same result. I mean, there's nothing wrong with doing it this way. It's actually a lot clearer what's happening. But that compared to this, they do the exact same thing, but for like smaller functions, this is actually a lot. Sometimes people think that this is cleaner, and I actually personally like this method a lot. But it's basically this very similar. You're just telling it for x in L, do x plus 2. And literally just put that in the list. And that very cleanly outputs 3, 4, 5, 6, 7, 8. So if you can sort of see, all of this contains a bunch of elements from this code up here, right? So if I delete this, you start with an empty list. The way I like to compose a list comprehension is I like to start with actually the for loop part, so I know what I'm going to iterate over. So I always start like for x in L, and then I always go back to the front, and then I think, okay, what am I going to do with each element? And I do x plus 2. And there you have it, the same thing. It takes a little bit of getting used to for sure, but I think like this is something that's worth practicing a little bit. Similarly, there's also dictionary comprehension. This one used a little bit less, but there are times where you use this, where you can also make a dictionary in this kind of way. And so because I didn't want to think of a new example, here I'm just creating a dictionary where each key is x and each value is going to be x plus 1. And it's the same syntax, but in a dictionary you can feed it in like the key and value before you do the for loop. Let me make this a bit bigger. Here we go. So very similar to this syntax, this basically creates a dictionary that has each key is the numbers and then the value is the number plus 1. Probably not the cleanest example, but hopefully still demonstrates the point. Something that's like a little level up is that you can also include conditions in your list comprehension. So here I have basically the same thing, x plus 2 for x in L. But you can also add an if statement. If is an even number. And so that's something that's also pretty neat that you get 4, 6, 8. These are just like, this specifically, like list comprehension, you will want to use them when you know you want to perform an operation on every single thing in a list. When you find yourself having to like sometimes create a new list and then do a for loop and then append things to lists, oftentimes you can do the same thing in a list comprehension.
So how is the L generating numbers, I guess? Like, because that's not a variable that you declared, right?
Oh, it is. Sorry. L is what I had generated at the start of this. I forgot to like.
Oh, wait. Okay. Yeah. I was like, okay, I'll just fix this, but I never. Okay. All right.
Yeah, but L is a list of 1 through 6.
Gotcha. Okay.
Yeah, I know that. Yeah, that would be confusing.
Okay. Thank you.
No worries. All right. So I think this is something that's worth spending maybe a little bit of time if you're comfortable with for loops already. But if not, like there's nothing wrong with writing for loops because it's literally doing the exact same thing. There's nothing more efficient about doing something like this. It's just in terms of like how it looks. I think sometimes this looks a little cleaner. You don't have to deal with like indents and stuff like that. I guess it's a little less. No, never mind. I was thinking about like, because you might have to like instantiate a new list, but here you are literally instantiating a new list. Never mind. Thinking out loud. Any questions about this part? Awesome. So section 3, now we're getting into the bulk of section 3, is just a lot of Python basics. And I just wanted to like talk through what I usually do when I'm given something like this. So this dictionary comes from the Using Nested Loops lab, where you can see like, it's like a soccer match with like the 2 teams and all their players. And nested dictionaries is a very, very common data type. When we get back to like section 9, when we're using like APIs to get data from the internet, a lot of times, or actually most times, they come in nested dictionaries. So it's very important to get used to working with nested dictionaries. And they do get kind of complicated sometimes, and it can be very confusing. And so that's where like knowing the intricacies of dictionaries can really come in handy. So here I have this soccer match dictionary. It is a lot right now. So let's say let's pretend that this is so big that I can't even read what's going on. I don't even know what's happening here. one thing I really like to do is explore the data first. Find out what its schema is. So schema is basically like, what are its keys? How is it set up? How is it nested? So I always start by just like printing information to find out what's going on. So here, okay, there's a lot of stuff going on. Type of soccer match is a list with 2 elements, cool. And then soccer match 0, because it's a list, I want to see what the first one looks like. You can see that's another dictionary here. When we're working with real life data, usually when you do this, it's going to be like another huge long thing. And then we just keep going down into the dictionary and see what's going on. So soccer match 0, we can see that soccer match 0 is just this home team dictionary. And so something that could be useful is, let's take a look at what keys exist, right? And we remember this by .keys, and we see, okay, so there's home team, away team, the country, number of passes, blah, blah, blah. And there are also players. And like through like scrolling up and down, you sort of figure that, okay, there must be more information there. And so let's take a look at players. And so we do that, and we see, okay, in players, there seems to be another list of things. And so this is a very, very cut down version of what you would be doing when you get data like this. It's just really like play around, take a look at its keys, take a look at what's nested. And like sometimes what I like to do if I'm working with something huge is literally take pen and paper and draw out the structure of this giant dictionary. And that really helps me sometimes. So yeah, that's something I do.
I have a question.
Mm-hmm.
So it seems like this is a list, and then dictionaries, and then lists inside. Basically, the list is the dominant form, and dictionaries inside the list. Are there ever dictionaries inside dictionaries? That can't really ever happen.
Yeah, you can totally have dictionaries inside dictionaries. Like, not this example, but yes, you can have dictionaries inside dictionaries, and we will definitely see that within the next like 3 weeks, where you would have to like call like the key of the key of the key, and that's something that is. So that's something that you can do. I think the lab right after this has dictionaries within dictionaries. Or no, the one that I was saying, like the functions with arguments lab, that one does have dictionaries within dictionaries, I think. Because I think that actually comes from the Yelp. That's actually Yelp data, and the Yelp data is like that as well. But really quickly, I wanted to use this as an example to talk about how we can write functions. And this is going to be me walking through my process with your help of how I would create functions. So cool. These are not questions that come from the lab. These are questions that I just made up. So we're gonna go through this. So here it says, write a function that counts how many players have even shirt numbers. So when you define a function, you gotta start with the def and then give the function a name. Count even shirts. And whenever you're writing a function, I like to think about what arguments should I have. And when you think about arguments, you sort of have to think about how are you gonna have to reuse this function? And if you are, like, what are you gonna reuse it on? In this case, I'm counting the players that have even shirt numbers out of just 2 teams. So from exploring my data, I know that I just have 2 teams of people here, and I just want to count how many people have even shirt numbers in these 2 teams. So it doesn't really need to be reused that much. And therefore, here I don't need to have any arguments. However, right now I'm gonna change the question to ask how many players in each team have even shirt numbers. So now I know that I need a function that will work per team. And therefore, I have to add the argument of like team. Does that make sense? Yeah, this is like the whole process of thinking how to start writing functions. So, okay, I know that I want to write a function that will work on a team. And so I have to go and think about what does my data look like for each team? And good thing that back here when I was exploring my data, I know that each team, and I'm gonna actually like comment this out so it's a little cleaner. Let's do, so soccer match index 0 is the first team. I'm gonna take a look at the type as well. I know that's a dictionary. So I know that I'm gonna have to run this function on a dictionary. Does that make sense? Sometimes you might want to manipulate your data so that it fits your function better. But for this case, I think this works fine. It's all right. When I'm writing functions, something I also like to do is test your function. So I'm going to just do this. I'm going to call this function in another cell. And I know that my input is going to be this. So I know I'm actually going to test it on this dictionary. And so when I'm testing, I'm going to test on soccer match index 0. Cool. So for the testing, I like to throw in print statements here and there. So let's see what happens if I print team here. Does anyone have a guess of what will output when I test the function? And it was a little like backwards. But when I'm using a function, basically what I have here will be assigned to team. So in this case, this function is just having me print team. So in that case, it's just going to print soccer match 0. So here, we can see that it's soccer match 0. For this question, we're counting how many players in each team have even shirt numbers. And if we remember that there's a player's key, this is going to be like the steps of my thinking. So, all right, I remember that within each team dictionary, there's a key that has players that has all the important information that I want. So in that case, let's see what like team players does. Run that and test that. All right, so that kind of like narrows down the data that we have here. So now I just have a list of players, right? And we can even print, what type it is. We can see that it's a list. We can print the length of it to see how many players we have. We have 11 players. So this is another way to like explore your data and test your function as well. So all right, we know that we're doing something in team players, and we know that players, that team players is a list. And so probably want to do something about like iterating through that list. So let's start creating some stuff in our function. And let's do like for player in team players, since we know that in team players, each element refers to a player, right? And again, I'm a big fan of print statements to help debug your function. Let's print player and see what goes on here. And we don't need this for now. Let's comment that out. Let's run that. Okay, we're getting there. We're slowly getting there. So we've printed each player. And you know that now player refers to this dictionary here. Yeah? So, all right, let's try and get even more granular to like the data that we want. So it seems that like, all right, there's another key here called shirt number, and that's exactly what we're looking for, right? We want to see if they have even shirt numbers, so let's take a look at that. So we go into player and then shirt number. Let's run that. Cool, awesome. Now we have a list of numbers. So up to here, does anyone have any questions? All right. Okay, I know it's kind of a lot. I think for especially if you're new to like creating functions and coding, I think like HackerRank is something that really helps with like making this process like click faster. I think something that definitely helped me, just like practicing writing functions. But anyways, we now want to see if how many players in each team have these even shirt numbers. So there are several ways we can go about this. One popular way to do it is you have a new variable that has that keeps track of how many people have even shirt numbers. And then here we can just have an if statement to see if, okay, if the number is even, let's add 1 to that even count. Does that make sense? All right, so let's try that. So here I know each player shirt number refers to the exact number. So here's where I can start with my condition. If player shirt number and modulo 2 equals to 0, and modulo means like the remainder when you divide it. Even count plus equals to 1. And plus equals basically increments. And then at the end, we know that we want to just have the count. So we can return even count. So before we run this function, let's check how many even numbers are there. There's 1, 2, 3, 4, 5. So we expect 5. So let's hope that is 5. Awesome. So this is one way to write this function. There are many, many ways to do this. I'm going to go through one more. Let's just copy this over here. Very similarly, I'm actually going to make use of our list comprehension. So we are going to go back to team players. And we're going to use that loop there. And actually, wait, let me undo this. So what I want to do now is create a list of all the shirt numbers. And we can do that with list comprehension as I showed you earlier. So what I'm going to do is I'm going to make a new list called shirt numbers, new list. And I want to loop through team players and just extract the number. So I know I'm going to do for player in team players. And what I want to do is just get the shirt number. And because now there's a for loop going on, I can do for player shirt number. So do we sort of see what's happening here? For player and team players is that list of dictionaries, I'm extracting the shirt number. And so just to test it, let's actually see what shirt numbers is. Run this and run this. You can see that I'm printing shirt numbers and it returns us all the shirt numbers. That's awesome. Next step, we can return, here, I'll separate out into two different steps. So now I can do like a filter. I can do a list filter, lambda, and I always use X, but you can use really any letter. And I have my condition, which is just the same as the one I used earlier, X modulo 2 double equal to 0. And I'm looping through shirt number. And let's, for the sake of testing our function, see what even gives us. Cool, all the even numbers. And then you can return the length of even, which is also 5. So that's just showing you that there are many, many ways that you can write a function. Cool. Here, unfortunately, didn't really have time to talk about while loops, but while loops are kind of an alternative to for loops. And what I hope is that you guys can like try doing this. I wasn't going to go through this during this session, but take a look at like the section labs on while loops and attempt this. This is a little bit tricky, but attempt this and we can talk about this problem during our one-on-ones, because if you can do this means that you understand how loops work and while loops work and breaks as well. Any questions? Yeah, so just attempt this. Here I suggest that you can try it 2 ways, but if you can do it 1 way, that's fine as well. And really quickly, just like a summary of the bottom half of section 3, they talk a little bit about like an intro to statistics. I'm not gonna go too in depth into statistics because 2/3 of module 2 will be on statistics. So just several like more qualitative questions, I guess. The 2 main things that we want to take away from the end of section 3 is measures of central tendency, as well as measures of dispersion. So central tendency is like an average, right? And you'll see that there's a difference between a mean, a median, and a mode. And just think about like, you know, what are some situations where you want to use each specific one. And then there are measures of dispersion that tells you how spread out is your data. Like if you have, let's say 20 students in a class and you're taking a test, it makes a difference if like, let's say everyone gets like a 75 and like only 2 people get like, one person got a 90, one person got like a 60. It's very different if your average is still 75, but you still have like a bunch of other students getting like grades all over the place. So that's sort of what measures of dispersion can tell you, is basically on average how far away from the average value are people at. Cool. So this is like pretty basic stuff. It also goes into correlation and covariance, but that stuff I will be talking about again when we get to mod 2, and it's less relevant for this mod. Any closing questions? I know that was a lot of stuff that we went through. All right then, just keep working. For the upcoming study group, I'm going to ask about this. So get, not study group, but upcoming one-on-ones, I'm going to ask about this, so get ready. If your one-on-ones tomorrow, don't worry. But yeah, I'm going to ask about this. Anything else I wanted to say? No, I don't think so. Cool. If there are no other questions, have a good night, everybody.
Thank you.
Thank you. Have a good night.
Everyone.
Have a good night.